Danger! I'll be handling corrosive acids and doing reactions in this video that produce deadly fumes. Doing these reactions without proper safety equipment could cause serious injury or death. Welcome back everyone to part 2 of the 25 troy ounce pure gold bar refining video. We're going to get right to it, but first what I'd like to do is take a look at this inquartation process, show you where I found it, and show you a couple of things that could cause problems, especially for new refiners. First thing I'd like to do is look at these constants that I have at the top of the page here. These are the numbers that I use to multiply by the number of grams of 10K to get the amount of sterling silver that I need to add to get a proper inquartation. 10K gold, I got 339.9 grams. I multiply that by this constant right here, 10K. Up here, see it says 10K, 0.635. I multiply the number of grams of 10K I have by 0.365, and that tells me I need 215.8 grams of sterling silver or copper, whichever your case may be. 14K, the constant is 1.265. And all I do is take the amount of 14K gold that I have, in this case it was 915.8 grams, multiply it by the constant, 1.265, and that tells me I need 1158.5 grams of sterling silver to properly inquart this amount of 14K gold, and so on down the list. Next, I'd like to talk about where the information for the inquartation comes from. It's out of this book, Refining Precious Metal Wastes by C.M. Hoke. And in his book, on page 52, she talks about getting an alloy that's 25% gold and 75% other metals. Up here she gives the calculations to use to get an alloy that is 25% gold and 75% base metals. Notice here it says the practice of making a button that's 1/4 gold is called quartation or inquartation. This is the only thing that I disagree on in this book. It says if you have doubts as to the fineness of the original material, add more silver or copper rather than less. And in my experience, if you add too much silver, the inquarted gold will fall apart, crumble into a powder, and cause problems when we try to separate the silver solution that sits on top of the powdered gold. In my experience, I've found that when I inquart the gold, there is a Goldilocks range that we want to stay inside. And what I've found is an alloy that makes 6.5K, or about 27% pure gold for the low range, all the way up to 8K, or 33% pure gold alloy. This area right in here will give the best result when we go to do the nitric acid boils. If we get below this range down into this area, then we run the risk of the gold crumbling as we do the nitric acid boils, and it'll form a fine powder of gold, or even worse, colloidal gold, that passes right through a filter paper. It makes it difficult to separate the silver-bearing solution from the nitric acid treatments from the gold that's left in our container. On the other end, if we go above this level right here, then the nitric acid takes longer to penetrate into the gold, and increases the time required that the unquarted gold must stay under the boiling nitric acid. And anything above 9K, and you've seen me do it, I put my wedding band in boiling nitric acid, and with the carat of gold this high, 14K, it'll just sit there and it will not be affected by the boiling nitric acid. So the lower we get close to this 6.5K range, the quicker the nitric acid will remove the base metals and silver from our unquarted gold. But the closer we are to having our gold fall apart and crumble into a powder and make separation difficult. The higher we get in this range, and the less likely we have, the less likely the gold will crumble, but it will take longer under the nitric acid boils. So, but if we stay in this range right here, 6.5K to 8K, then we will get the best results when we boil the unquarted gold in nitric acid. Here's a few pieces of gold that I came across as I was sorting through the material. This looks like carat gold. And if you didn't know any better, you'd think that it was. But what it really is a gold-plated bracelet. It's a very thin coating of gold over brass. If this thing gets added to our carat gold, like that in here, and then we include this gold-plated piece in our weight when we go to calculate how much silver to add or copper for the inquartation, then it's going to throw it way off, and I'll end up with way too much silver in the batch. That's why it's important to test each piece with acid, especially for the newcomer. I've been doing this for many years now, and I can tell right away that this was a piece of gold-plated material. You can see some of the gold plating is coming off right here, and you can see the brass underneath of it. Another thing that causes problems, this is a 14K gold set of earrings that I came across, and they're full of plastic. It's got a thin coating of gold over plastic. I mean, there's still going to have some value there, but if I include the weight of this plastic inside these earrings, then what that'll do, that'll throw my numbers off, and I'll end up having too much silver added because I counted this plastic as carat gold. So it's important. That's why I take these big puffy earrings like this, I cut them with a pair of cutters, cut them open, and make sure they're full of air. Every now and then you get something like this that's full of plastic. And lastly, I've got a piece here that's obviously not carat gold. I mean, I could tell it in a heartbeat just by looking at it. But if you look there, it's marked 14K gold. Now this is a piece of brass. It was probably gold plated at one time, real shiny. But to the newcomer, they might look at that and just assume because it's marked that it's gold. This is brass. If this makes it into our carat gold, and we use that weight of this thing to calculate how much silver to add to do the inquartation, it'll throw our numbers off, and we'll end up putting way too much silver in our carat gold, and we'll end up below this lower limit of 6K down into this area, and our gold will crumble, fall apart, and make separation of the silver solution from the solids, the gold that's left in the beaker. It will make that almost impossible. And what I can do to get rid of this plastic is just take this and put it in a melt dish and melt the metal into a little button or a bead, and then we can just add it right into our carat scrap here and refine it after we burnt away all of the plastic material out of the middle of this piece. Okay, to kick this thing off, I've got some gold in here, And what I want to do is measure an amount of gold to do the inquartation. So I've got a handful here out of the 14K gold bin. Just going to add this. You see we've got 305.1 grams. So we take 305.1, multiply that by our 14K constant over here, times 1.265. And that tells us we need 385.9 grams of sterling silver. So I've got our gold here that we're going to inquart, and I've pre-measured this silver to speed things up. This is all sterling silver from our bin. You're gonna fight me, ain't you? Of course. All right, I've got and I'm calling for 385.9. I've got 384.6. That's close enough for this inquartation. All right, I'm gonna gather the silver up in a little container here. And then we're gonna go out to our electric furnace. And we're gonna inquart this carat gold with this sterling silver. Here's our gold silver we're going to inquart with. See if that spoon will fit down in there. It will. I've got my crucible heating up. Now what I'm going to do is just add a few strands of carat gold to the crucible now. As this heats up, getting a little bit of smoke coming out of our crucible now. As you can see, we're starting to heat up. While we're waiting for that to melt, I wanted to show you my little rig here that I've got. It's a 5-gallon turkey fryer bucket full of water. I've got this piece of wood here that I've fashioned to stick into the handle like so that it creates an angle. And I'll pour the molten metal on that piece of board and spatter the molten metal into the water that'll have ice going into it. Down in the bottom I've got a circulating pump to circulate water. So I'm going to put the wood down in here so it'll get nice and soaking wet. And then we'll just wait for this carat gold to melt up in our electric furnace, and then we'll start adding some of the sterling silver to it. We've been heating now for about 15 minutes. Take a look down in here and see what it looks like. It's red hot. The metal's starting to become molten down in the bottom down there. It's like any other oven. The more you take the lid off to peek at it, the longer it takes to melt. All right, let's take our graphite rod here, and I'm going to push the metal down a little bit if I can. And now what we'll do is add a few more pieces. Need to get all this metal in the crucible. I calculated that we'd have enough metal, about 20 troy ounces is what we're going to end up with this charge. All right, let's just let this heat back up now. The metal is molten in that crucible, but in a second you're going to see me try to stick a fork handle down in there, and it would not go into the molten metal. All right, we got all the gold in there now. We can start slowly adding pieces of silver. Cut these pieces of silver up so that they'll fit down into the crucible. And then once we get all the silver in here, and this thing gets really hot and molten, then what we'll do is take the graphite stirring rod and stick that down in there and stir it up real good. Alright, I'm going to feed a little bit more silver in here now until we got this crucible full of molten metal. And then once that happens, we'll be able to stir it up with our graphite rod. Okay, I've found that if I preheat the silver with this torch before I stick it in the furnace, it works much better. It goes much faster. Sticking an ice cold piece of silver down in there, it just kind of, it's like trying to push a knife through a rock. So I'm heating this up to redness and stick it down into the furnace. It goes right in. I've only got about 4 pieces left here, so I'm going to preheat these with the torch, get them into the furnace. I'm going to cover it up and let it get nice and hot, and then we'll preheat our graphite rod and get in there and stir it up. And then once we get it stirred, we'll pour it into our tub of water and make those granules. I'm a little apprehensive about doing this. This is the first time that I've ever attempted to do anything like this. I'm going to preheat my rod here and make sure it's nice and hot before I stick it in that molten metal. And then what I think I'm going to do is hold the torch on the top of the furnace there to keep it hot while I do the stirring. Here we go. Stick it down into the furnace now. Oh yeah, that's molten. And I can feel the bottom. Seems to be working pretty good here. And my rule of thumb when we're making an alloy like this is when I feel like I've stirred it long enough, I count to 20. I ain't got there yet. Doesn't feel like I've quite got there. Alright, I think that's good. So I'm going to start counting to 20 now, and then I'll take it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Alright, that worked out pretty good, man. I'm just going to let that continue to heat now. Got a couple of big blocks of ice here in cottage cheese containers. Put that down in my bucket here. And I want this water fairly chilled when I do this so that the granules do not stick together. If the water's too warm, the granules will have a tendency to stick together. So we're almost ready to do this pour. All right, my tank is ready. Okay, our charge of metal is ready. I'll take the lid off. And now I'm going to point the camera down here at my my tank of water. I'm just going to take our crucible and pour the water onto that piece of board there to form our nice granules of encorded gold. All right, now you'll notice that I left the crucible in the furnace, and that's so we can immediately recharge it with some more gold here. I've got this next batch ready to go in, so I'm just going to start dropping some of this in there and utilize the heat from the crucible. All right, once I get this in here, we'll take a look at the encorded gold down in the bottom of the bottom of our tank there that we just poured. That's the benefit of leaving the crucible in the furnace when we do the pour, so we don't cool it way off and keep the heat for the next charge. Oh yeah, this is much better. If you remember the last time I did this, it formed a giant pancake, and these small granules now will present more surface area to the acid when we do the nitric acid boil next. And what I'm going to do is just move this metal out of the way so that when we pour the next charge in, it will not try to weld to the metal that's already down there. All right, that's ready for the next charge. Okay, now that the crucible is hot, now that the furnace is heated up, this is going to go much quicker. That last charge of metal, the first charge of metal that we just did, took an hour. Whoa, there goes something here. That thing popped. That's probably an earring that I forgot to squeeze and break open. And those things will pop like that and spray metal everywhere, so you got to watch that. But now that the crucible's hot, we should be able to zip right through this. Like I said, the last charge that we just poured took an hour and about 20 minutes to get everything melted in the furnace here. But now that we're hot, this batch here will go much quicker. Oh yeah, it's only been about 5 minutes since I put that last bit of gold in there. Add some more here. We should have this in here within 10, maybe 15 minutes. Then we can start adding our silver. It's going pretty good here now that the crucible's heated up. These are pieces of pure gold. As a heart, it was 995 gold. A little button from the sulfuric acid stripping cell for gold-plated stuff, and a coin here. I don't know what all else is in these metals, so I'm going to run them through and add them to this charge, and put another additional 25 grams of silver for those pieces of metal in with this charge. Let me add this now. So going in. Okay, I've got all the gold in there now. And so what we'll do is set up. I've got my charge of silver to quart this gold with, and we'll start preheating this and adding this silver to the gold. Okay, we're going to start adding the silver to this now, and I'm not going to do any more of the molten metal stuff here. I'll do the rest of this off camera, and then when we got this all of our gold quarted, I'll come back and we can go to the next step. All right, as you can see, when I preheat the metal, it just kind of goes right on down in there. Here's a difference when we put a cold piece in. It kind of sticks in there. It does not go down into the charge of metal. It just kind of sits on top. All right, this spoon is our last piece of silver that needs to go in to finish this charge of metal. Okay, well, that second charge of metal is heating up so we can stir it. I'm going to get our third charge ready. This is the last of the 14K. We got 297.3 grams. So what we need to do there is 297.3 times our constant, which is 1.265 for 14K. So I need 376 grams of sterling silver to properly quart this 14K gold. And I've got some silver here pre-weighed out. 376 grams. That'll be perfect. So now our third charge is ready to go in the furnace. We're going to stir this second charge now. I'm going to heat up our stirring rod. You don't want to stick an ice cold graphite stirring rod down in that charge of molten metal. I'm just going to heat this up a bit. And now, pull the lid off here and stir this metal just like we did the first one. It's got a little bit more metal in it than the first one had. It's important to get a nice alloy here. Got a little bit of crud floating to the top there, probably some dirt and stones that we missed when we went to clean this out. Stir that up real good. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. All right, let's prep the tank here. Put the piece of wood in the upright position. That water's still ice cold. And now we're going to go ahead and pour this charge of metal into our tank. Pull the lid off. Oh yeah, it's nice and hot, nice and molten. That's what it looks like in there. Let's see if I can manipulate the camera down here properly. And here we go. Here goes the second charge of metal into our tank right now. Okay, got that in there. Let's right quick go ahead and start adding this third charge of 14K material right on in while we got a hot crucible. Okay, let's look down in here and take a look at our bounty in here. Look at that, man. I think this is coming out much better than the last time I tried to do this by just pouring it in a metal container of water. These granules will present much surface area to the nitric acid, so this is coming along real nice. I'm just going to scoop these back out of the way now for the next charge. I didn't put any ice in here the second charge that we just poured in because the water was still cold, but now it's starting to warm up a little bit, so next time on the third charge I'll add some more ice. Now I'm down to our last charge of metal, and I don't know why I didn't think of this earlier, but I've combined the 10K and the 18K in this charge. And that's all of it right there. But I should have been heating this up instead of putting it in cold. That will burn off junk that might be on here. Plus, it'll cause this process of adding the metal into the crucible to make it go much quicker. If our metal is hot when we put it in there. Didn't even think of it until the end. That's okay. This is all new to me. This is a brand new process. I've done this before, but not in this fashion. So it's just watching me learn as I go here. Yeah, by heating this up, it's going to make this go much quicker. Just wanted to include that on the video. This is the last charge, like I said. And once we get this done, we'll have the encording process complete. This went much quicker. It took about 5 minutes to get all the metal to go into the crucible there. I should have thought of this much earlier. I've been working here for about 3 hours now, and we could have had this wrapped up maybe a couple hours ago. So, all right, I'm putting the last few crumbs of metal in. Okay, this is our last charge of metal. I'm going to
heat our stirring rod up real good here. This charge of metal includes all of the 10K and the 18K gold. So the crucible's nearly full. Alright, here we go. Let's see what we got here. Stick our rod down in here and stir this up real good. The reason we stir this is to make sure we get a good alloy to thoroughly mix the silver, base metals, and the gold to make a homogenized alloy. Alright, it feels like I've got it stirred enough, so now I'm going to count to 20 and keep stirring. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Alrighty. Alright, we've got this final charge of metal nice and hot in here. And we're going to pour it into our tank of water here and make some nice granules. Alright, this thing has been a real workhorse. I'm going to turn it off now and give it a rest. And let's look at our loot here, man. This is looking real good. Let me unplug this pump, get that out of there. And here is, okay, see that? It's kind of blobbed up a little bit. That's quite all right. It'll fall apart, but that's because the water warmed up just a touch. It wasn't quite as cold as when we put the ice in it. Now we're going to dump this water off and collect the imported gold. Now we'll pour the tap water off of our imported gold. And we'll collect it in this metal pan that I have sitting in the sink here. All right, let me get this water out of here. Look at all that metal, man. I'm not used to working with these large amounts of metal here. When I refine gold, I usually do maybe 2 or 3 ounces. Spray bottle. And we're going to spray down the remaining gold out of our bucket here. A jug of distilled water here, and what we're trying to do is rinse off all of the chlorinated tap water out of here. Put a container down here so we don't lose anything down the drain. Here's the piece I was talking about. It kind of congealed, welded together a little bit, but it's loose. That's because the water started heating up there for that last pour that we did. It'll be fine. This is all good nice granules. It's going to present a lot of surface area to the acid when we add the nitric acid to this. And that's what we're after, is to get a nice quick parting with hot nitric acid in the next step here. There's no easy way to do this. I mean, the camera's right in my way here. So what I'm going to try to do is, without shattering my beaker, add this metal to this 5-liter beaker. Wish me luck here, man. This is the first time I've ever done anything like this. Here we go. Come on in there. Nice and easy for me, please. Metal and glass is not a good combination. Wow, that thing's heavy, man. Alright. That's our quarted gold. Let me rinse this out and get the rest of the pieces into this beaker. And I think what I'm going to do is give this one more quick rinse here with distilled water, just to make sure we don't have any chlorinated tap water in there. Chlorinated tap water will react with the silver nitrate that we're getting ready to form, and form silver chloride in our reaction beaker here, and that's something we don't want to happen. All right, let me get this. Good Lord, look at all that. Okay. This will conclude part 2 of the 25 troy ounce pure gold bar refining. We've got all of our gold quarted now, sitting in some distilled water, and it's ready for us to be adding some nitric acid to it. And we're going to boil out all of the base metals and silver with hot dilute nitric acid boils. And we'll do that in part 3. The hard part's done. I started on this about 4:30, and it's about 20 minutes to 10 right now. So what is that, about 5 hours or so? This is, like I said, this is the hard part. It's done. Now we just keep adding nitric acid, get the base metals out, add more nitric acid, get the base metals out. And I gotta tell you, I don't think I've ever seen this much quarted gold in one spot at one time, ever. This will conclude part 2 of the 25 troy ounce pure gold refining. Thanks for watching.